So we've been talking about vertical reflections like last week, this week. If you have the negative sign on the outside of the function, if it's on the outside of the function, it's a vertical reflection. And then this would be a reflect in the x-axis, which I will write over and over again, so I'm not going to write it right now. Oh, my bad. Not for me. Sorry. So we've got the negative sign on the outside of the f of x. I just put those brackets in so you can see it's on the outside of the f of x. Horizontal reflection, which we're not doing yet today, but we will. It will be when we have the negative sign on the inside of the function. Okay. And then here's two pictures. The first one would be a horizontal reflection. And the second picture is a vertical reflection. The vertical flips up and down, but the line of reflection for the vertical is the x-axis. And then for the horizontal reflection, that flips left or right because it's horizontal. I'm making up words today. Horizontal, but the line of reflection is the y-axis. So some students get confused and write the wrong axis because horizontal means x, but it's flipping over the y-axis. Vertical means up and down y, but it's flipping in the x-axis. So people get confused about that. So we got to make sure that we know that it will sound weird. But if you drew a picture, you reflect up and down, that's the x-axis. All right, some of this we've done. So some of this should be review. Graph p of x equals negative x squared and its parent function, then describe the transformation. So I have made a table for you, and we are going to use the points that we always use, but I like to use 7 of them, and these notes only have 5. So I'm just going to divide this up and this up. So I'm going to do 7 of them. So we use -3, -2, -1, 0, 1, 2, 3. The reason why I didn't just add some to the bottom is because the word vertex is sitting there right in the middle. I want to make sure the vertex was still at 0. Then we put all of our x's into x squared. So we square all the x's every single time. X squared, we're going to get 9, 4, 1, 0, 1, 4, 9. And I said that so fast because I've done it so many times that it's memorized. So the more that you write this stuff, the quicker it will be memorized. You'll have less work to do. Now we have a negative sign in front of x squared. Actually, before I do that, let's just plot the parent function real fast. So the parent function 0, 0, at -1 or +1, it's 1. At the 2's, it's 4. At the 3's, it's 9. I'm not going to connect it with a solid line. I'm just going to make a dashed line. That way you can tell the difference between my graphs. Of course, if you use color, you can definitely tell the difference between your graphs. Okay, so now we are going to be graphing p of x, which has a negative sign in front of the x squared. You guys tell me, what transformation is the negative going to do? Derek. Yes, but we're going to write the way I was phrasing it. Say that. What's the first word you said? Reflect, yes. So we're going to say reflect, and then I'm going to change one of your words. Reflect, yeah, in the x-axis. And I know it sounds like so weird because we don't talk that way, but that's how it's written in math. Reflect over the x-axis is the same as writing reflect in the x-axis, and that's the way that it's phrased. Now, the operation of this negative is like -1 multiplied by x squared. So what I do in this column is I times everything by -1. And I'm multiplying the y values because this is a vertical reflection. So all of my y values, I multiply them by -1. That just changes all of their signs. And then I always graph the ordered pairs that are on the furthest out x and the furthest out y. So if you're using a table, I have the points you can graph. If you're not using the table, if you're just reading and you know it's a reflection, well, we can just figure that reflection out by imagining the x-axis is a mirror and mirroring it. So I either used my table points or I looked and said it's a reflection, that's a mirror. I'm doing the table every time because when they get more complicated, the tables will help you so much. The end of the year, we'll do those squiggly sign graphs that we looked at like the first week. Actually, they're not very hard once we get there. We're not ready to be there now. But once we get there, they're not really hard. It's just if you don't know how to use a table, then they're going to be really hard. Oh my gosh, my graph is so ugly. I was sitting to the side and I didn't look straight on. Let me make that better looking. There, that looks better. Okay, the next example. By the way, so there'll be some like this in your assignment where you'll have to fill out the table and graph it. The next part of the practice is something called draw a quick sketch. So part of your assignment will say draw a quick sketch. And for the quick sketch, you do not need to be exact. You'll see there's no numbers on the graph. That's just to save you some time, okay? When it's got the whole like grid, that's when you're going to be exact. These will say quick sketch. You don't have to be exact. We need to state the parent function, then the transformations, and then draw a quick sketch of both. So I'm going to look at the parent function for each of these first. Question A. Jacqueline, what's the parent function for question A? Absolute value of x, yes. Absolute value of x. Question B, our parent function, f of x equals Ethan. So the parent function is going to be just the x and its operation. It's not going to be like the numbers added on. So the parent function by itself would just be x squared. These parent functions, we got, you guys, we talked about like the first set of notes. And then question C, Grayson, do you know what the parent function is for question C?
F of x equals x root squared. X squared.
Yeah, that's right. So you can see question B and question C have the same parent function, but they don't look the same anymore because they have different transformations. So on the graphs, we're going to quickly sketch what each one looks like. So Jacob Clark, what does an absolute value graph look like? What do absolute values look like? What letter is that? A V, right. So I'm just going to quickly sketch a V. It has its vertex, its center right at 0, 0. So when I sketch that V, this would be wrong. Also, it's not the correct graph, but like if you put a V over here, that would be wrong. It has to have its center at 0, 0. Okay, how about x squared? Gavin, what's x squared look like? A U shape. And then for the third one, that is another x squared. So that's a U shape. Okay, we've got our rough sketch. Now we're going to do transformations. So question A has a negative in front of it. Brecht, can you help me with what the transformation is for A?
Reflect in the x-axis.
Perfect. Reflect in the x-axis. So I'm going to rough draw that. We stood up and I said, what is this? And you guys said reflect. Like that's all we have to draw is it going this way. Now, you guys can tell this is a V that flipped down because I used two different colors. If you're doing this in pencil or using the same color, may I suggest that your parent function is dashed so we can tell the difference. Otherwise, it just looks like two lines crossing. You can't tell color-wise how they're different. Okay, question B. We've got x squared plus 5. I'm going to call on Jackson.
Would it be translate left 5 units?
It would not. Let's talk about why. Is that plus 5 on the inside of the squared? It's on the outside. So outside is vertical. What should it be?
5 units?
Yes. Translate up 5 units. So 1, 2, 3, 4, 5. There we go. There's my U shape translated up 5 units. And you guys, you know what? That's not super accurate, but I can definitely tell the most important part is that it was translated up 5 units. That's what you're showing me. You just don't have to take a long time and make the graphs beautiful. And then question C. Ryan. Question C. What's that minus 2 do?
It has this go right.
Do you remember the fancy word? That means to slide it. What's the word that means to slide?
Translate.
Yes. Translate.
2 units.
Perfect. Translate 2 units to the right. And so with my graph, 1, 2, there's my new U. So a bunch of your questions in your homework, you just have to do this stuff. Okay? All right. Now, I did not tell you absolutely had to bring it today. Just curious, how many people brought their graphing calculator? Nope, different question. How many people do not have a graphing calculator today? Okay, so that is more than half. So tomorrow, write yourself a note. Tomorrow you need your graphing calculator. I'm not going to show you how to do it on the graphing calculator today because you don't have it. If you already know how to do it, that's great. What?
All right, on my phone. Sorry.
Nope, that's fine. So make sure you bring your graphing calculator to class. It is a requirement for this class to have one. We've already gone over that the first day, but you need to be bringing it because we will do stuff on the calculator and then we'll do stuff by hand and then so on. All right. We talked about reflections and then we talked about stretches and shrinks. Remember, I pulled on your arms vertically or I pushed them down vertically. So those are the stretches and shrinks, the vertical stretches or shrink. So where you'll see that, here's an equation and it has a time symbol. I'm just going to make it a bracket because that would mean times as well. So y equals a multiplied by a function. So a is going to be that factor that stretches or shrinks the graph. If I said a was 5 and I was doing 5 times the graph, do you think that would make it bigger or smaller? Bigger. If I said half of the graph, that'd be smaller. That's common sense. So this is vertical, this is common sense. So if the a value is greater than 1, it's going to make it bigger. It's going to be a stretch. If the a value is between 0 and 1, that's a shrink. Why can't it be less than 0? What would happen if I had y equals -5 absolute value of x? What would that? Yes, check.
Make it negative.
It would make it negative, but would that negative make it a stretch or a shrink, or? Because this says a stretch is greater than 1 or a shrink is between 0 and 1. So what's negative 5 do? Ryan, sorry. The negative is a reflection in the x-axis. Remember we talked about that today already? Yeah. And then the 5 would be the B value, or the A value, I'm sorry. So the 5 would stretch it. The negative sign would flip it. These are two different transformations. So instead of thinking them together like -5, it's negative and a 5. Okay? So graphing and describing stretches and shrinks, the very first thing I do is look at my equation. F of x equals 2 times the absolute value of x. Yanzi, what is the parent function? F of x equals what, hun? Absolute value. Is that what you're saying? Absolute value, yeah. So that's my parent function. So my parent function points would normally be x's -2, -1, 0, 1, 2. And then what happens when I absolute value them? They're all positive. So we have 2, 1, 0, 1, 2. And then when I plot those, I've got my parent function points. If you want to draw the whole parent function graph, that's fine. Just make sure I can tell the difference between your parent function and your transformed function. So the next column, we have to apply our transformations. So we look here and we say 2 absolute value of x. Sila, if there is a 2 multiplied by the absolute value of x, is that going to stretch it or shrink it? Common sense, Sila. 2 times something bigger, it makes it bigger, right? Yeah, so we're going to write vertical stretch by a factor of 2. By a factor of 2 means I am multiplying by 2. But it's fancy because it's math and we got new vocabulary. I am multiplying by 2 by a factor of 2. So what I do in my table, because this is a vertical stretch, I go to the y side and I multiply all of my y values by 2. So instead of 2, I now have 4. 2, 0, 2, 4. You always graph the outside x, comma, outside y when you make tables. I'm writing the ordered pairs. You don't have to write the ordered pairs. You should be able to see them. But just in case you don't know where I'm getting them from, I wrote them. And then I can come over here and I can graph -2, 4, -1, 2, 0, 0. Now, we did talk about this when we were making our name graphs. Some of you maybe didn't have to worry about the number in front when you were doing the name graphs, but some of you did. Does anybody remember what I was calling it, that number in front, when we did the name graphs? Started with an S. Slope. It's like 2 lines. That's the slope. It's up 2 over 1, up 2 over 1. But that only works for lines. So I don't always like to call it slope because when we start doing the U shape, those aren't lines. But with absolute value, they are. Questions? Doing okay? How about B? We've got 1/2 x squared. So we first need our parent function. Carson, can you tell me what the parent function is? Yeah. So f of x is x squared is our parent function. So my parent function points for x squared would be -3, -2, -1, 0, 1, 2, 3. And then my y values, I just square all of those, and they all become positive. 9, 4, 1, 0, 1, 4, 9. Brian, we're going to do half of x squared. So this is like half times x squared. So I need to write a transformation for that. Okay, it's not being squared, it's on the outside, so it's vertical. Do you know what it is, Brian? It is a shrink because 1/2 makes something get smaller. Vertical stretch by a factor of 1/2. So by a factor of means I multiply by a half. So I'll take all my y values, multiply by half. I forgot to graph my parent function. We'll do that in a moment. So I'm taking half of 9. Well, that's 9/2, or you might think of it like 4.5. Okay, I didn't graph my parent function. I'm going to graph that guy really fast. 0, 0, 1, 1, 2, 4, 3, 9. And then reflecting some symmetry. There we go. So now my ordered pairs I'm going to graph when I graph the new function is going to be -3, 4.5. -2, 2, -1.5, 0, 0, 1.5, 2, 2, 3, 4.5. So this one was a vertical shrink, so you can see that it's not as wide. It opened up a little bit. Now, it says student practice. I am not going to give every single person in here enough time to do start to finish before I go over any of it. So start working on it. You can see where your questions are right away. And if you have some, raise your hand. If you don't have any, just keep working on it. But while I interrupt, if when I put up the parent function, if yours is wrong, you better fix it. Okay, so start working on it. Go through the steps that we just went through. Find your parent function first. Then list the points for the parent function. I will do it in a moment. So the parent function would be the thing with the x that's not the 3. You're not sure. It's going to be the thing that's with the x, but it's not the 3. I hope you see better. Yeah, that was good. I mean, I don't know how you did that, but show me sometime. Okay, Amy, what is your parent function? You had it correct. What's your parent function, hon? Yes, that is correct. I just want to change my color. F of x equals x. That is saying, and some other people had y equals x written down. Either of those is fine. When I say function, I write f of x. But if y equals x, I start putting in x's. What does my y equals x column look like? Hannah, what's my y equals x column look like if I put down my x's there?
You'll have it's not absolute value, so just -2, -1, 0, 1, 2.
Y equals x. So this column equals the first column, right? Exactly what we're saying. Y equals x. They are the same. And then you have a transformation that has a 3 in it. Maddie, did you have time to do your transformation yet?
Yeah.
What'd you get?
I said it was a vertical stretch by a factor of 3.
Very good. Vertical stretch by a factor of 3. What does that mean I do to the graph? What's that mean, Jack? No, but I totally said graph and I meant to say table. What, sorry. What does that mean I do to the table? What?
I think it means that you, in the last column, you multiply everything by 3.
Yes. By a factor of 3 means multiply it by 3. That's what by a factor of means. Bless you. So my regular line linear parent function is right straight down the middle there. Then when I graph my ordered pairs, -2, whoops, I went the wrong way, -6. Nope, that's not at -2. -2, -6, -1, -3, 0, 0, 1, 3, 2, 6. When I graph those, oops. This was a vertical stretch. So it should be getting closer to going straight up. It's closer because it's going up faster. Multiplied it by 3. It goes 3 times as high. And with a line, what is that 3? The what of the line? The slope of the line. It's steeper than the first line. Okay, same stuff, different question. Next question. Number 4. I won't let you finish it without checking in and making sure you're doing it correctly. What? Write it down. What's the parent function? Don't yell it out. Write it down. Then fill out your table. Okay, vertical is vertical, C-A-L. Yeah, if you have to type in vertical on Canvas and you type it in wrong, you don't so fix that now. Oh my gosh, put your calculator away. You are using your calculator to multiply by 2. You are in big trouble in here. I know, it's not a 2, right? We will multiply together. We will not use a calculator to multiply by 2. Hint, you have to multiply by 2. Jay, what is the parent function? Let's see if I probably didn't write it ever. I've been saying it. It's just the part without the 0.2. So that's absolute value x. Here, I'm writing it. Absolute value x. What time is our class done? Yeah, we're gonna have to skip ahead. We're gonna skip ahead. Okay, the last section is just asking you to say the parent function. So like for question A, f of x equals absolute value of x. And then it's asking you to say all the transformations. So from absolute value to x to look like all of this stuff, we have a negative in front. That's a reflect in the x-axis. And then the +5 is inside of those bars. So if it's inside, it's a horizontal. What's that +5 going to do? Translate 5 units where? Left. And then the +3 is on, or sorry, the -3 is on the outside. So that's vertical, which is common sense. So we'll go down 3 units. And then this last one, parent function is f of x equals x squared. The negative sign is a reflect in the x-axis. And then the 4 is a vertical what? Times by 4 is a vertical stretch by a factor of 4. So you'll have some questions like that on your assignment as well. We'll do the graphing calculator stuff tomorrow. So bring your graphing calculator. And if you needed help doing this one without a calculator, I can go over that later. But we should be able to do this one without a calculator. I'm gonna still fill it up, fill it out. The bell might ring any moment. You have an assignment on your module. If you didn't notice, there is a worksheet. What's 2 times 2? If you have 1 decimal, then what do you do to the answer? If you're multiplying 1 total decimal, what will your answer have? Decimal place. It'll have 1 decimal place. All right, you guys have a wonderful day. Oops.
You, Brian?